Hello, and welcome to this PV Tech Talk webinar in conjunction with Trina Solar. The title of this webinar is Designed for Success, Bifacial PV Power Plants Built to Last and to Provide the Lowest Levelized Cost of Energy. My name is Sean Roach, and I'll be your host for today's webinar. Joining me is David Garmendia, Trina Solar Product Marketing Manager for Europe, and Paula Shidlauskas, Global Head of Supply Chains at Green Genius. The first part of this talk is going to examine the basics of bifacial technology, which David will do, and then Paulis is going to take over and look at some proof of concepts and results from the field. Before we hear from our speakers, some quick housekeeping from me. Today's webinar is going to last around 1 hour, and there will be opportunities for audience questions. You can use the dialog box on your screen to submit those questions. The webinar will be recorded, and it will be available on demand via PV Tech later today. But without any further ado, I'm going to hand over to our speakers, and David, you are first.
Okay. Well, hello everyone. Thanks for being here today, attending this webinar. Thanks Sean for the introduction. This is David Garmendia from Trina Solar Product Marketing Department at Europe organization, and leading the product support for key strategic accounts. As it was explained, we will start with the first part of the presentation, more focused on bifacial principles and bifacial technology main basics. So the idea for this part of the webinar and the agenda is what you can see in the slide. First of all, we will start with the market trends and let's say the market share of bifacial modules and bifacial technology in the market. Then we will continue with our main principles and basics explaining the bifacial technology. Then next, we will see the influence on the main affections of key components of a PV plant, such as modules, mounting systems, and inverters, due to the use of bifacial technology. And then we will conclude with, let's say, a set of guidelines on key parameters at PV plant system level that you must take care about when you are designing PV plants with bifacial technology. So starting with the market trends on bifacial it's important to say here that our bifacial technology is not a new technology. It has been present with us since a really long time ago. But it was not until 2018, 2019, but this technology was started to be deployed massively in the industry. As you can see in the picture from PV InfoLink, in 2019, the market share for global shipments of bifacial modules was around 9%. So it was such kind of a niche at that time. But in 2020, and despite of the pandemic situation, this year was closed with a global market share of bifacial module shipments of 21%. On 2021, we closed the year with a 38% market share for bifacial module shipments, and this year is forecast to reach even a 50%, and the same or even more for the years onwards. And it can be even more if we focus only on utility scale segment. In this case, we can be talking about roughly a 70% market share for bifacial modules. Having said this, what we have, or which is our experience in Trina? Well, in Trina Solar, we have a really vast experience on bifacial technology and bifacial modules. And nowadays, our cumulative figure on shipments for bifacial modules is roughly about 20 gigawatts worldwide. Well, having said this, let's try to start with some basics and some principles that are explaining the bifacial technology. Well, first of all, as you can see in the slide, the energy that is being produced by a bifacial module can be expressed as the energy coming from the front side plus the energy coming from the rear side of the module. Easy, right? So this apparently is a formula has been passed almost everybody in this industry for the last years. Why? Because it's quite straightforward to model and to estimate the energy that is coming from the front side of a module. But this process is not straightforward. I should say it's quite complex when we are talking about the rear side of a module. For the reason, nowadays, the most common approach in the industry in order to discuss about bifacial technology is what we call bifacial gain, that tries to express the energy coming from the rear side of a module as a fraction of the energy that is provided by the front side of a module. And reaching this point, it's important to mention two relevant considerations. First one is that the power conversion efficiency that is happening on the rear side of a module is not the same as the one happening on the front side of the module. And the second consideration is that the sunlight that is reaching the rear side of a module is generating a behavior that is absolutely different to the one happening on the front side of a module. So related to these considerations, there are coming two new definitions. The first one is the bifacial ratio as the relationship between the irradiance on the rear side versus the irradiance on the front side of a module. And the second one is the bifaciality as the relationship between the efficiency in the power conversion of the rear side of a module versus the one happening on the front side. And this bifaciality is an inherent, intrinsic feature of a module. So based on these three concepts, bifacial gain, bifacial ratio, and bifaciality, you can see how it can be expressed the energy coming from a bifacial module. And continue with the main, let's say, guidelines and principles for bifacial technology. We can say also that the irradiance on the rear side can be split in two main components. The first one is the diffuse irradiance. The diffuse irradiance is basically the irradiance coming from the blue sky and the clouds. In a clear day, in a sunny day, it's only accounting for roughly 15% of the total irradiance. However, in a cloudy day, it can account for bigger percentage. And the second component is the reflected irradiance. This reflected irradiance is the one that is coming once that the sunlight is reflecting in the earth or in the surface, and is captured by the rear side of the module. So at this point of the webinar, probably the audience is already guessing what should be needed to be done if we want to maximize the bifacial gain of our PV plant. Well, first of all, increase the bifaciality, which is something inherent to the module. And secondly, to increase the irradiance on the rear side. And also increase, obviously, both components, the diffuse irradiance and the reflected irradiance. And in order to do that, it is needed to tackle about some key parameters at PV plant system level, such as albedo, pitch, height, or mounting shading, or rear shading, that we will see later on more in detail from a quantitative perspective. So once that we have, let's say, the basics and the principles explaining the bifacial technology, let's try to see which are the main changes or the main affections of key components of a PV plant due to the use of bifacial technology. Well, first of all, starting with the modules, you know that in a bifacial module, it is needed to replace the solid backsheet that is included in a monofacial module by other material. But the important point here at the module level is the cell. The cell has to be changed, as you can see in the slide, in the picture on the slide, from a monofacial cell in which the backside is just pure aluminum, blocking any possibility of capturing light on the rear side, into a bifacial cell. And in this case, there is a new texturization process in order to make the rear side of the module available to capture light and to have the same light trapping on both sides, rear side and front side. Also, at this point, it's worth to mention that the bifaciality, this concept that we have already just some minutes introduced, is being affected or is changing by the technology of the cell. So as you can see in the right side of the slide, if we are talking about a P-type technology, we will also talk about bifaciality values in the range of 70%. However, if we move to N-type TOPCon technology, we will have bifaciality values in the range of 80% and even higher if we move to heterojunction technology. So we mentioned before that in a bifacial module, it is needed to replace the solid backsheet by other component. But which is the best component to use on the rear side of the module? Well, we have brought for today's webinar this picture from PV InfoLink that we consider that is really interesting. In this picture, you can see a traditional debate that was happening in the past in the market between which material to be used, glass or glass transparent backsheet. And as you can see in the picture, there is a clear dominance in the past and for the near future on the glass configuration. Having said this, which is our view from Trina Solar side? Well, in Trina Solar, we are clearly believers on bifacial glass configurations. Why? Well, mainly because we consider that these configurations provide a really high reliability value on the long run for the modules. There are multiple benefits associated to the use of a glass configurations, but just to mention some of them, for example, they are more resistant to salt spreads, acids, or alkalis. The moisture penetration is zero, almost guaranteed. It contributes to reduce the invisible cell crackings. And for me, the most important one, it provides to the module more mechanical reliability, more mechanical stiffness and strength. And this is even more important in utility scale whenever that you are using every time bigger and bigger modules. So continue with the mounting systems, right? Well, first of all, here, just to mention that while in Trina Solar, we are well known as module suppliers, but we are also delivering to the market mounting systems for utility scale segment applications in all the configurations, in fixed steel structure with our fixed origin product, and also in tracker configurations with our Vanguard 1P and our Vanguard 2P. So having said this, which are the main parameters, for example, in a tracker 1P that are affecting the bifacial gain and therefore the energy production of a PV plant? Well, there are several, but the main ones are the torque tube size, the torque tube height, the pulling height, and the central gap. But again, which is the important point here, how these parameters are influencing the energy production and the bifacial gain. So you can see here in the, for example, in the upper graph, which is the influence of torque tube size and pulling height on this bifacial gain. And all these graphs are based on real measurements that we did some time ago. In this case, for the same pulling height, as far as we are able to decrease the torque tube size, we are able to increase the bifacial gain. On the other way around, for the same torque tube size, as far as we increase the pulling height, we are able to increase to the bifacial gain and therefore the energy generation. And what about the mounting height? How is affecting the bifacial gain? You can see in the bottom graph. As far as we are able to increase the mounting height, the torque tube height, we are able to increase to the bifacial gain and the energy production. But it's not everything about maximizing the energy production and the performance, right? It's also related to and guarantee the reliability on the long run. And for a 1P tracker, that means that it has to be able to withstand with really high levels of snow load and wind loads. For that reason, for these parameters, a trade-off must be reached off in order to guarantee both, maximize the performance and the energy production, but without compromising the reliability on the long run. And also related to mounting systems, we consider that it was worthy to mention here also the way in which we track the optimum angle in a 1P tracker and a tracker in general. Why? Because this has changed dramatically when the use of bifacial technology. We are moving from a, let's say, classical astronomical approach in the algorithm, just using the day, the time, the longitude, and the latitude, to more, let's say, to a smarter tracking algorithm. So in our case, in Trina, we are using what we call SuperTrack. It's our algorithm, which is based and or is composed by two sub-algorithms. So the first one is the STI, the Smart Tracking Algorithm, which is taking care of maximizing the capture of diffuse irradiance on the rear side of the modules. And the second component is the SBI, the Smart Backtracking Algorithm, which is taking care of maximizing the capture of reflected irradiance on the rear side of the module, especially when there are terrains that are not pure plain and that they have some hills and also to avoid the effect of shadings in this kind of sites. So with this super track, we are able to maximize or to increase the yield of your PV plants in the range of 3 up to 8%, depending on the sites and the conditions and etc. But this definitely is changing the game with these new strategies on tracking algorithms and on tracking the optimal angles for the tracker. Well, we talk about the modules, we talk about the mounting systems, but what about the inverters? Well, here we can say that generally speaking, the use of bifacial technologies implies higher DC-AC ratio. You know that the DC-AC ratio can be defined as the relationship between the DC peak power on the PV array divided into the energy or AC energy or AC power that can be delivered by the inverter to the grid. And as you can see in the picture, it delimits the clipping losses, which is the phenomena that is happening whenever the DC power is higher than the inverter rated power. So normally in the market, all the designers are going for a DC-AC ratio higher than 1. Why? Because it is needed to compensate some non-ideal phenomena, such as the one that is happening when you are designing a PV plant. Normally, you are using the STC conditions for the modules, but this is not happening quite often in the PV plant. Also, the rating of the power versus temperature and other conditions that are not ideal when you are designing a PV plant. So a general rule in the industry is just using DC-AC ratio in the range of 1.2 up to 1.4 whenever that you are using bifacial technology. And I should say that the best advantage of using high DC-AC ratio is that you are going to have your PV plant producing at nominal power or rated power longer period of times. And that means that the energy production of your PV plant is going to be increased, and therefore the revenue streams for your PV plant. But on the other way, there are also some constraints regarding the use of higher DC-AC ratio. One of them is that you are increasing the capex. And second one is that whenever that there are clipping losses, the inverter is not tracking the MPPT point. But both topics can be managed normally during the design of a PV plant using this type of DC-AC ratio values. So here, just to conclude this part, I mean, it's important, the message here is that it's really important to set up a really good value of DC-AC ratio whenever that you are designing with bifacial technology. And now, once that we saw the main effects and affections on the key components, the idea would be to try to provide you a list or a setup of our key parameters on guidelines about key parameters at PV plant system level whenever that you are using bifacial technology, and also to maximize the bifacial gain of your PV plant. Well, the first parameter is what we call albedo, that we also mentioned before. But before starting, what does albedo mean? Well, the albedo is the ratio between the reflected irradiance and the global horizontal irradiance in the ground surface, and is a non-dimensional value that can vary from 0, which means that your surface is a perfect absorber, up to 1, which means that your surface is a perfect reflector. So, and the albedo can vary with many other parameters or variables, like the color of the surface and others. So for that reason, it's really important that you characterize the albedo of your PV plant. And related to this, in Trina, we repeat many times several testing campaigns in order to characterize albedos and the estimated bifacial gain related to different surfaces and albedo. For today's webinar, we bring some examples based on a PV plant located in China with a fixed tilt configuration and a tilt angle of 27 degrees and a module height of 0.4 meters. And there with these 3 different albedos and surfaces: grass with an albedo of 17%, sand with an albedo of 35%, and white paint with an albedo of 75%. And based on the real measurements, the estimated bifacial gain in this consideration could vary in the range of 6% up to 25%, and even more if you use a tracker in a state of fixed tilt structure. So again, really important message here is really relevant that you characterize in a really accurate way the albedo of your PV plant. You want to have an accurate value for your bifacial gain or the bifacial gain of your PV plant. Another relevant parameter is the pitch of the GCR. You know that the pitch is defined as the distance between two adjacent rows of a trackers in a PV plant. And therefore, the GCR is defined accordingly, as you can see here, as the module area, what we call L in this picture, divided into the pitch. But here, the important point is how this pitch or GCR is influencing the bifacial gain. The answer, you can find it in the picture just on the middle of the slide. In here, you can see that as far as you increase the pitch or you decrease the GCR, you are able to increase the bifacial gain. But also you are increasing the capex, because a higher pitch means that the layout optimization of your PV plant is not the best one. So again, it's not everything black or white. You have to reach a trade-off with the pitch and the GCR in order to get a really good value of bifacial gain, maximizing the energy performance, but also at a reasonable value of capex. Well, next, there is also relevant parameter that you have to take care when designing with bifacial module. And this one is the mounting height or the module elevation. And here, generally speaking, also we can say that normally higher module elevation increase the radiation on the rear side. Why? Because modules that are located higher up from the ground, they are able to capture or to see more diffuse irradiance, and therefore they are contributing to increase the bifacial gain. Also, modules that are located higher up from the ground, they receive more reflected irradiance, and therefore they contribute to increase the bifacial gain. And last but not least, modules that are located higher up from the ground, normally they work at lower temperatures, so they have a better thermal behavior with a lower derating of power versus temperature. So they contribute to have a better performance. And the last parameter that is also relevant for you to take care about is the shading. Normally, the shading is something that you have to avoid in all your PV plants. Why? Because regardless if the module is monofacial or bifacial, the shading is always reducing the performance of your module and reducing the power output of your module. For that reason, as you can see in the slide and in the picture, the torque tube size is normally the main source of shading that happen in a real PV plant. And just as reflection about that, if you want to have a really accurate bifacial gain value, you need a shading modeling. For the reason in Trina Solar, we developed some time ago what we call view factor model, which is a model based on real measurements in many parameters. And related to this model, we are able to provide really accurate values for your PVC simulations. In particular, two main parameters, the structure shading factor and the mismatch loss factor. And well, just to conclude this first part of the webinar, let me make a summary with the key takeaways and conclusions for this part. First of all, we show as the bifacial technology is the dominant technology nowadays and for the future, with an expected market share above 50%. Also, we explain a little bit and we discuss about bifacial gain as the most common approach in the market for explaining bifacial PV plants. And also we introduce some concepts such as bifacial ratio, bifaciality, diffuse irradiation, reflected irradiation. Also, we show and we make some analysis about main affections of bifacial technology on key components. At module level, we discuss a little bit about the glass-glass configuration versus glass transparent backsheet. In mounting systems, we analyze the effect of torque tube size, torque tube height, and purlin height in the bifacial gain and in the energy production. And finally, in the inverters, we explain and we discuss also about how important it is to set up a really accurate and good value of DC-AC ratio if you want to maximize the performance of your PV plant. Finally, we tried to provide some guidelines and about a key of set parameters at your PV plant level, and we discussed the effects on parameters such as albedo, GCR, module height, and setting. And last, unfortunately, we didn't have today to explain more in detail some case study, but just to let you know that also as part of this analysis on bifacial technology from Trina Solar, we ran several case studies on bifacial technology assessment versus monofacial one. These case studies were located in two different places, one in Spain and one in Germany, as different examples of different conditions of irradiance and solar resource. And one of the conclusions that we got from these case studies is that, for example, in general speaking, but especially in south of Europe or in really countries with a high level of irradiance, normally the tracker plus bifacial module is the best combination if you want to reduce the LCoE, right? And in terms of sensitivity analysis, the higher the albedo, the higher the module elevation, and the bigger the central gap amongst the modules, the higher bifacial gain, the higher energy production, and the lower LCoE, and also the higher internal rate of return for your PV plant. So that's all on our end. Just to let you know that all these topics and many other more are already in our guidebook that you can download for this link from this QR. So we encourage you to download in order to get further detail on that. So that's all on my end. Thank you very much again for your attendance. And now we continue with the second part of the webinar that is going to handled by Green Genius, in this case by Paulius. So Paulius, the floor is yours.
Thank you, David. Hello, everyone. My name is Paulius Šidlauskas. I am a global solar supply chain manager for the last 5 years in Green Genius. So, as David explained, I would like to give you a proof of concept, basically, where we compare bifacial and monofacial technologies. So to give you a bit of understanding who we are, so Green Genius is developing, building, and operating solar, biogas, wind, and hydrogen projects. Of course, solar is the oldest one. The first one plant we built is 10 years old already. And hydrogen is, of course, the fresh thing for us. Yeah, so overview about the numbers, let's say. So we active in 7 countries in Europe. We operate 20 megawatts of biogas projects, 250 colleagues working around in Europe. Our pipeline is 1.5 gigawatts, including all the segments we are active. Last 5 years, we invested close to €500 million in renewable projects, and up till today, we have 210 megawatts of solar projects which are running now. So about the solar portfolio. So majority, of course, implemented projects are in Poland, then is Ukraine, Lithuania, Belarus, and Latvia. In the late development, we have winning Italy, then Poland with Spain, and Lithuania as catching up. And in early development, we have Lithuania, the first one, then Poland, Romania, and the rest of the southern countries. So why bifacial decision was made kind of 2 years ago, and from that moment every single megawatt we design and build in Green Genius is equipped with bifacial modules. So I would like to give you an idea of what result we have. So Subačius PV plant is located in Lithuania. Here we have our first ever bifacial PV plant. So what we did, we chose inverter and made a two strings basically with the monofacial modules to have a data, and which will give you an idea after this presentation. So just running through quickly about the parameters of the PV plant. So it's located, as you already heard, in Lithuania, where we have like 1042 kilowatt hours from square meter. Energy output for the PV plant calculated, it's 1267. The size of this PV plant is 1.78 and a half megawatt peaks. The CAC overload ratio is 1.13. It's equipped, the modules equipped on 1P tracker with module setup already explained, and it's using string type inverters. Pitch is 6 meters. Yeah, so jumping deeper to the details. Here you can see the on inverter level when do we have the high irradiance. So 3 different MPPTs, the 3 strings on the same inverter, and as you can see, different gains are like plus 4.1% and difference, and on another one is plus 5.8. This is what David was explaining, every small area influencing. Maybe it's a grass like grown taller, or it's just a simply no grass and there's a sand, more flatter area, and this is the gain. This is the difference we can see. So with the low irradiance, as you can see, it's even better, but probably it's because of the tracker, right? So then overall, I took this year, current year data, and you can see overall we have average of almost 60 kilowatt hours from kilowatt peak, or 5.3% higher higher yield. So going further, talking about capex, so just 2 parts are different from this our particular case. It's of course modules. Currently in the market, probably everyone knows that difference between the same power, same size module will be really small. It's probably maximum up to half euro cent per watt. And the tracker is more expensive slightly as well, because you can see the graph, it's almost invisible. So you have slightly higher on bifacial, because at the time, with the experience we had, we decided to lift the tracker 20 centimeters higher than usual, old-fashioned, I would say, right, with monofacial modules. So this is the main difference, because anything else has no influence on the overall capex you need to invest in the PV plant. OpEx, interesting topic, as you can see, but from the point of bifacial and monofacial comparison, there is no any difference. You don't need to do anything or spend anything more. You can talk about grass cutting or something. No, the data I took, it's nothing more than the usual PV plant, so it's equal. Then we have, of course, the final thing, calculated levelized cost of energy. And yeah, you can see actually the picture of this particular plant, and the result of this calculation is 4.02% lower levelized cost of energy. So I think it's a great result, and you can of course then multiply by your portfolios in megawatts or even gigawatts, and you will see that, yeah, it is worth to go. Now, everyone afraid of bifacials, double glass modules, and this is my personal experience doing that. So handling module from producer from factory till the installation plant, it has nothing extra, nothing different, because the packaging is the same. Yes, it is a bit heavier, but still nobody charges you for that. It's like no container price, right? Now installing, taking the module, right, which could be a question as well. I mean, on construction phase, so still 28 kilograms versus 32. So you need 2 people to carry on with the module. So it's EPC partner, or you're doing yourself, you will need 2 people to do that. So it's no increase comparing monofacial with bifacial. And then installation itself, so there is no different in module. It's the same frame. Assembly is the same method. So no increase in capex. So you have nothing more. And to give you conclusions, what you just heard, right? So as I explained, slightly higher initial investment, which depends on the module price and the tracker you want to lift. What David explained, right? So it needs to be calculated. Proven lower LCoE, what we just saw. And well, using bifacial modules actually gives you no additional risk compared to monofacial. Thank you very much. I hope you liked.
Brilliant. Thank you very much, guys, for your insights and presentations today. We've now reached a section where we can take audience questions. So this is a quick reminder to everyone listening. You can submit questions today using the questions tab. There have already been a load submitted, which is great to see. But before I get onto them, I just wanted to pick up on a couple of things that you spoke about during your presentation. So firstly, David, you've spoken about the dominance of glass-glass configuration for bifacial modules, and we've listened to your talk about Trina's view on all of that. I'm just wondering if you could elaborate a bit more on what Trina thinks about that.
Yeah, sure. Thanks for the question, Sean. Yeah, I mean, definitely, as I tried to mention before, I mean, on Trina solar views, I mean, glass-glass configurations definitely is a really robust solution. And we prefer this because mainly the reliability in the long run. We consider that, yeah, these are configurations provide a better mechanical performance and other benefits. So among these benefits, I mean, there are several of them, right? We just mentioned during the presentation some of them, but starting for the first one, let's say, for example, glass-glass configurations are more resistant to spray of acids, alkalis, and salt, right? Why? Because when you use a monofacial module with a classical backsheet, this is let's say an organic polymer, means that it's basically plastic, that whenever that you expose this material for a long period of time to the air, to the climatic conditions, is being degraded. So it's not so resistant to corrosion or to other climatic conditions. On the other way around, for a glass-glass configuration, I mean, we replace this plastic material by an inorganic polymer, right? And this one is really more robust to exposure to climatic conditions and etc. Right? Secondly, we also talk about let's say the zero moisture penetration, right? Again, if you are using a backsheet configuration, a glass backsheet configuration, this polymer, this plastic can be degraded, right? And during the time, probably it can happen that some part of this moisture can get into the module and into the cells, and this can generate a really big damage on them. However, this is not happening. This is guaranteed that it's not happening with glass-glass configurations, right? Also, we mentioned about the cell cracking, the invisible cell cracking, these things that could happen sometimes during the transportation or during the installation. whenever that you use a glass-glass configuration, it's like you have a sandwich between the cells, right? So it's really most resistant to the stress and to the shock. Therefore, I mean, it's almost guaranteed that you are not going to have, or it's going to be more resistance to this potential failure. And last, but for me, the most important thing is that using glass-glass configurations provide the modules are really bigger or better values in terms of mechanical performance, mechanical stiffness, right? So it means that whenever that you make a really big pressure and stress on your modules, the degradation or the deformation that is going to suffer your module, if you use glass-glass configuration, is going to be smaller. And therefore, the power attenuation is going to be smaller too. This is something that we have tested several times in the past, and also that our modules, our finite element modules, also replicate under different conditions and locations and sites. So yeah, I should say that I think I have elaborated a little bit more about the benefits. But again, if you want to see further detail, you can download our guidebook that it's covered this part with many other topics.
Okay, thank you, David. The next thing I'd like to ask you about, and also related to a lot of audience questions we're getting at the moment, is albedo. So you kind of explained to us the importance of albedo characterization within a project in order to kind of accurately estimate bifacial gain. And you said that albedo properties can change and vary as well. So I'm just wondering if you could elaborate a bit more on that and give us some further insight into how they change.
Yeah, definitely. I mean, I guess that many of the audiences is thinking and is asking about the albedo because it's really important for a bifacial PV plant, right? And you know that as explaining is the definition between, or the relationship between the reflected irradiance and the global horizontal irradiance, right? It's true, it's changing. The albedo can change. It's not a fixed value. It can change because of the ground surface, because of the color of the surface, right? Normally, lightly colors and smooth surfaces are providing bigger values of albedo, right, in order also to maximize the bifacial gain and the energy production. But again, I think the important message here is that it's not only about going for higher values, that it is, but the important thing is to have an accurate value of the albedo of your PV plant, because this is going to provide really important, or it's going to be really important for the bifacial gain and for the, let's say, production model of your PV plant, and therefore for the revenue streams of your PV plant. And maybe sometimes when we talk about albedo, and this has been a really big debate in the industry about albedo characterization, right? Sometimes this process is being simplified, and it's not easy at all, because the albedo is, as I mentioned initially, is not a fixed value. It's changing. It's changing, for example, during the year. It's not the same albedo value for the same terrain in a winter time that in the summertime, right? Why? Because the properties of the surface are changing, and the distribution of the light, the angular distribution, is changing also accordingly to the summer or to the season size. But even more, also the albedo is changing during the years, right? Because the terrain of your PV plant can vary. This has been, let's say, small plants, or the properties of the surface can change, right? So if you want to introduce if you want to have a really accurate value of bifacial gain, you need an accurate value of albedo that you can introduce in the PV simulation to have a really good values of energy productions at GR0 and PR of your PV plant. And then you have an accurate estimation also about your revenue streams, LCoE values, and internal rate of return. But again, I mean, it's not so, my message here is that it's not so straightforward. It takes time. Obviously, if you can do real measurements on PV plant to characterize the albedo of your PV plant, is better, right? Rather than just done simulating. And also you have to take into account, just to finish my part, that for example, the albedo is also more sensitive whenever that you go, for example, to higher latitudes. Why? Because normally there you are using bigger pitch or higher values of pitch and higher inclination tilts, right? So and therefore, in these conditions, also the albedo can be even more sensitive, right? So general. Now, try to be careful because the albedo is let's say, quite challenging to characterize. Try to do it as best as possible if you want to have a really accurate value for the bifacial gain.
And thank you for that as well, David. That was very clear. I just want to pick you up on something you said towards the end of your presentation, and it's also been echoed in the comments a lot, which is the difference between bifacial and monofacial modules. And you said that Trina had conducted some studies and assessments on the difference. I'm wondering if you could provide the audience with a few more details about, firstly, the scope of that study and also its key conclusions.
Okay, yeah, it's also a really good point. I mean, well, first of all, I should say that apart from the case studies, I think that the best is the real experience, right? And Paulius, I think, already showed us really a really amazing piece of content of how real experience is about bifacial technology and how bifacial technology is working on real plants, right? But having said that, it is true that from Trina Solar, we ran in the past several case studies in order to evaluate the real performance of bifacial technology and bifacial modules versus monofacial ones. In particular, I can mention one case study that we ran with a technical advisor called ATA, Axon Technical Advisor, in which the scope was to make this assessment in two different locations, one in Germany and second one in Spain, and as two different examples in Europe of different conditions of solar resource and irradiance. So, and in these two locations, they consider different configurations, mono and bifacial module, and also they consider a fixed steel structure and 1P tracker. So, and with all of them, all these parameters or all these boundaries, what they did is they create a layout for each one of the PV plants and the configuration, and they make a detailed analysis on the CapEx, means making a breakdown about in each one of the PV plants configuration, how the CapEx looks like, in sense of which is the breakdown between modules, mounting systems, the inverters, etc. They did similar way with the OpEx, how the OpEx cost is evolving during a 25 or 30 years life expectancy of the PV plant. And for sure, they make PV simulations with all the configurations, mono and bifacial fixed steel 1P tracker, in order to evaluate which is the energy production and the PR for each one of the scenarios. Finally, with all of them, all this data, they create a financial modeling in order to estimate the LCoE and the internal rate of return in each one of the scenarios. And as I tried to explain in the beginning, for example, for the case of Spain, it was clear, the conclusion, that the bifacial module plus the tracker was the combination to provide the lower LCoE and to maximize the internal rate of return. However, in the case of Germany, both configurations means bifacial module plus tracker and bifacial module plus fixed steel structure, they provide really great values of the lower values of LCoE and best values of internal rate of return. So this is also an important message for those of you that maybe you are not really familiar with trackers, or you have really some constraints in your locations for using trackers. Just keep in mind that if you use fixed steel structure, you also have benefits using bifacial technology on a fixed steel structure. And yeah, I should say that this is basically my main rationale here. Again, if you want to see all these pictures in CapEx, OpEx, energy production, and even the summary of the financial modeling with LCoE and some other financial metrics like wage cost of capital, etc., you can download the guidebook, and you can find it there.
Thanks very much for that, David. So I'm just going to pull out a couple of, I think we have time for one or two audience questions. So Paulius, there's one question here which says, in the Bifacial PV project, what was the difference between real production and energy assessment in the development phase? And if you could explain a bit around that, and I think that'd be interesting for the audience.
Yes, thank you. Thank you for the question. Yeah, the Bifacial PV plant is performing at its best. Evaluation made and development designing phase, of course, was done. Yeah, up till now, during those 1.5 probably year, the difference, the gain actually from what was estimated is like 2.3% more. But well, it is not really related, to the bifacial monofacial, because but I mean, if we comparing assessment and the real data, yes, we have like 2.3%. Yeah, thanks probably to O&M team and the equipment we choose.
That's great. Thank you, Paulius. One of these questions is also asking about the expected CapEx and OpEx costs that come with white paint for increasing that albedo effect. I'm just wondering if you've conducted any studies around that, or if you can give any indication on that.
Yeah, I can take it.
Yes, I do.
Well, I mean, the albedo normally is not affecting the CapEx, right? The CapEx is more focused on the breakdown by main components, I mean, modules, inverters, trackers, installation, right? But it's true that if you are, in some cases, and we have some experience with some developers and some customers, that during the life expectancy of the PV plant, they make some, let's say, arrangement of money to in the OpEx, right, to, let's say, keep the same albedo value, right? Because as explained before, the albedo can vary during a year and can vary during the years, right? So from year 2 up to year 25 or 30. So in some cases, financial modelings of end customers, IPP or promoters, they have a really, let's say, accurate values for the internal rate of return and LCoE, and mainly this is coming from the energy production. And if you go down, this energy production is also really related to the bifacial gain. And if you go one step down, what is affecting your bifacial gain? Albedo, GCR, pitch, what we showed before, right? So relating to the albedo, normally in order to try to minimize the gap that Paulius was mentioned before between designing phase and the real phase in terms of energy production and bifacial gain, some developers are, let's say, giving reserving some part of the money in the OpEx to, let's say, clean the terrain or clean up whenever that there are plans, or just to analyze if something can be done in order to keep the same properties on the surface, etc. Right? But again, the message here with the albedo is not only to going for higher albedos, that it is. The tricky point here is to try to have an accurate value from the real albedo, your real PV plant, and when to have basically the same value whenever that you are designing. So there is, in order to have a really minimum gap between what you are having during the design phase and what you are having whenever that the PV plant is in operation mode.
Thanks very much, David.
Yeah.
Unfortunately, guys, that's all we have time for today. Thank you very much, David and Paulius, for joining us, and indeed the audience for tuning in. Just a quick reminder that today's webinar will be available on demand shortly, and will be on PV Tech website. Our next PV Tech Tech Talk webinar will be on the 27th of this month, and it's examining the evolving customer demand of residential solar. More details of that will be released shortly. But finally, thanks again, and we hope to see you next time.
Thank you, everyone, for attending.
Thank you.